All right, here I see I've got quotient rule, I've got a chain. So this is pretty complicated. We should simplify it down to U-substitution. And I'm going to go ahead and choose U to be 1 minus 4x squared. And so then we need to do du, which would be negative 8x dx. And then just kind of see what I've got here. So if I plug in my u, I can get it down to this, which looks a little better. I need to get everything in terms of u. So I take my x dx here and need to replace it. So I'm going to solve for x dx, divide by negative 8. So I'm going to have negative 1/8 du to substitute in. All right. And then, so that's my integration that I'm going to do. I'm going to simplify it first. So I'm going to bring out the negative 1/8 in front because it's a coefficient. I'm going to change the square root u to the negative 1/2. And then I'm ready for my integration. So I'm going to add 1 to the exponent, which would be positive 1/2. Then I'm going to divide by that. So divide by 1/2 would be 2 over 1. And then I've got plus c. Your 2 and your 8 reduce down to 4. So I'm going to have negative 1/4 u to the 1/2 plus c. And so that would be my answer, but I'm going to plug in my u that I chose earlier. And so that is my answer. You can write it with a square root if you want instead of the 1/2. So I chose the right u. Let's just say, so what if I chose a different u? None of your choices for u are wrong, but well, they're kind of wrong because they're not going to help you. So let's say I chose something more complicated for u. If I put the square root with it, and then I did du of that, and that's a chain rule, so I'd have to do 1/2. So I'm doing derivative of the outside to the negative 1/2 times derivative of the inside, so negative 8x dx. And then as I try to simplify this, if I plug in that u that I chose, now it's not square root u, it's just u, which is even easier than before. But then I have this x dx to get rid of, and look how complicated I've made this problem. I've got an x dx, but I've got to get rid of all that stuff. So this u would be a mistake because it just makes the problem even more complicated. So that's what I'm saying with you got to choose your u wisely and try to pick one that's going to help you simplify the problem. We've seen integration like example 4 before. We've had these e's with difficult exponents, but we could kind of simplify it by doing U-substitution. So if we let u be the exponent, and then we do derivative of that, which would be 5 dx. So if I fill in my u, that'll be e to the u dx, but we need it to be in the same variable, in terms of the same variable, so I want to solve for dx. So that would be 1/5 du if you get 5 to the other side. So then I've got e to the u 1/5 du. So now everything's in terms of u. And then bring the 1/5 in front. And so I've simplified my integration, and now the antiderivative of e to the u is just e to the u plus c. And there's that 1/5 in front. And then you just plug your u back in that you chose at the beginning, which was 5x.